From OpenGL Supervival 7th Edition, Part 2, Chapter 7, Drawing Commands, Instancing. In this episode, we will learn how to use glDrawArraysInstanced. We will implement grass field. This document explains all the required details how to implement grass field. I would highly recommend you to read this document. Also, I assume you have watched my previous video. Download current video source code. Show in folder. Unzip it. Rename 055 grass field. Copy. Paste in your working directory. Open up Visual Studio Code. Electricity and magnetism. Select folder 55 grass field. Click this button. grass.cpp, hit enter. Click grass.but. Click this button. Grass flag. Click this button. resp.txt, hit enter. Ctrl B. I will close welcome window. Select grass field. I will copy and paste these things. Ctrl Home. If my source code does not build on your machine, either you have my older library or you haven't set up the environment properly on your machine. In such case, if you scroll down, you can find all the required tools by control-clicking these links. You can download updated latest libraries and install them by watching my previous videos listed here. All the videos whose title starts with the setup, we make environment settings for our tools. In our previous episode 54, we learned Bitwise operation and random number generator. If you haven't watched my previous video, you may not understand how to implement this grass field. I will not concern myself whether you watch my video or not. Include CPG, SDD, extensions. Include OpenGL SB7, class grass field, public SB7 application, semicolon, declare main. We provide grass field, the class name here. With this, open up this command prompt. You should see OpenGL Supervival 7th Edition, dir cd 055 grass field, icx cl grass.cpp o i.exe qscd c++20 ehsc md link subsystem console, hit enter. cls I. It should build and run successfully. Now I will copy this command string. Copy, paste it here. We can use no equal to. Copy, paste it here. I will delete this part. With this, we can build like this. At resp.txt, hit enter. cls I. Of course, it should build. If you want to use NVIDIA CUDA compiler, OpenGL Supervival 7th Edition, CD 055, grass field, NV, CC, SDD, C++20 grass.cpp on.exe x compiler md d is for debugging build x linker subsystem console. Hit enter. Then you can also build using nvcc CUDA compiler. I will close it. Now select grass field. In this section, private, public, using base. SB7 application is our base class. Public, right click, go to definition. Scroll down. We will copy from startup on resize. Copy, paste it in the public section. Now I will remove all keyword virtual. Copy, Ctrl H, replace all. Now close it. Override, copy, paste, paste, paste. I will delete set window title. In this part, set window title, grass field, on resize, base, info, window width, base, info, window height. We have to call this function at least once. Then base on resize WH GL viewport 00 WH. Now we will rebuild CLS I. Now our window is grass field. Close it. In this section, program, load shaders. In the private section, GL unsigned int program. Here, private GL uint load shaders. I'll make it static. GL uint shaders. SB7 shader load file name grass but GL vertex shader. Copy, paste, remove trailing comma, fragment shader, semicolon, return SB7 program link from shaders. We pass shaders, shader count 2, delete shaders true. Now I will close this file. Arrange side by side. This is fragment shader, this is vertex shader. In the vertex shader, version 460 core. In back 4 free vertex. Out back 4 color. Uniform map 4 model view projection matrix. Layout binding 0 uniform sampler 2D grass palette texture. Layout binding 1 uniform sampler 2D length texture. Layout binding 2 uniform sampler 2D orientation texture. Layout binding 3 uniform sampler 2D grass color texture. Layout binding 4 uniform sampler 2D band texture. In case of grass palette texture, we will be using one-dimensional texture. Now, in our previous episode, we created random.cpp. In this file, I will copy this and paste it here. Please understand, we created this function in our previous episode. I will fold it up. In this section, backpo random, backpo int seed, int r mix bits seed, copy, paste, 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 g, we pass r, b, we pass g, a, we pass b. So r, g, b, a are bit mixed integer. Return backpo plot r bitwise and 0x 3 ff over 10 24 point f. Copy this, paste, 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 g, b, a, remove trailing comma. So we are returning random vector. About these things I explained in my previous episode. If you haven't watched it, my previous video listed here. Please watch it, otherwise you cannot understand my current session. Press Ctrl B. I will make it bigger and fold it up. Here, matpo construct rotation matrix, plot angle, plot sine t sine angle, plot cosine t cosine angle, return matpo backpo cosine t 0.0 sine t 0.0 backpo 0.0 1.0 0.0 0.0 copy paste negative sine t cosine t. I will arrange like this. backpo 0.0 0.0 0.0 1.0. This is rotation matrix. Rotation with respect to y-axis. Now, for the main, I will scroll up. Here, plot x offset, plot gl instance id, we shift by 10 minus 512.0 f. Copy, paste. G offset. We use bitwise and 0x 3 ff. Backpo offset, backpo x offset 0.0 f, c offset 0.0 f, int number 1 mix bits gl instance id, int number 2 mix bits, we pass number 1 offset plus equal backpo plot number 1 and 0x ff over 256.0 f 0.0 f. Copy this, paste number 2 semicolon. Now back to text coordinate offset xz over 1024.0f plus back to 0.5f semicolon. Plot band factor texture band texture text code r times 2.0 f. Plot band amount cosine v vertex y. Plot angle texture orientation texture text code r times 2.0f times 3.141592f. This represents 2 pi. Mat for rotation construct rotation. Scroll up rotation. Copy paste angle. Back for position rotation times v vertex plus back for 0.0f 0.0f band amount times band factor 0.0f, then plus offset position times equal back for 1.0f texture length texture text coordinate r times 0.9f plus 0.3f 1.0 1.0 1 element 2 element 3 element 4 element GL position model view projection matrix times position. Now color texture grass palette texture texture grass color texture text coordinate r plus backpo random backpo gl instance id xyz times back3 0.1 f 0.5 f 0.1 f 1.0 f semicolon. This represents 3 elements. This makes 4 elements. Now we completed vertex shader. Now in the fragment shader version 460 core in backpo color out backpo output color void main output color color. In the vertex shader we defined out backpo color in the fragment shader in backpo color. Now we rebuild CLS I. We have some error message 78 incomparable type in initialization 78. It should be back to. We rebuild CLS I. Now we built without error. I will make it smaller. Scroll up